On the morning of August 6, 1945, the city of Hiroshima looked completely normal. The streets were busy. People were walking to their offices. Children were heading to school. Shopkeepers were opening their stores. No one in the city knew that within a few minutes, history was about to change forever. At that time, World War II was still ongoing. Japan had been fighting for years, and the war had already caused massive destruction across many countries. But what was about to happen that morning had never happened before in human history. At around 8:15 a.m., people in Hiroshima noticed an aircraft flying high in the sky. It was an American bomber called Boeing B-29 Enola Gay. The aircraft was flying at about 31,000 feet above the city. Most people on the ground didn't pay much attention to it. During the war, aircraft sometimes passed over cities, so it didn't seem unusual. But inside that plane was a weapon unlike anything the world had ever seen. The bomber was carrying a single atomic bomb called Little Boy. At exactly 8:15 a.m., the bomb was released from the aircraft. It began falling silently toward the city. For about 43 seconds, the bomb dropped through the air. People below had no idea what was coming. Then suddenly, a blinding flash of light exploded in the sky. The bomb detonated about 600 meters above Hiroshima. For a moment, the entire city was filled with a light brighter than the sun. The temperature near the explosion reached millions of degrees Celsius, hotter than the surface of the sun. Buildings instantly collapsed. Streets disappeared under the force of the explosion. People close to the center of the blast were instantly vaporized, leaving only shadows on walls and ground. A massive shockwave moved across the city at incredible speed, destroying thousands of buildings. Within seconds, fires began spreading everywhere. Then something terrifying appeared above the city. A giant mushroom-shaped cloud began rising into the sky. It climbed higher and higher, eventually reaching nearly 12 kilometers into the atmosphere. In just a few moments, around 70,000 people lost their lives. Tens of thousands more were injured. But the destruction wasn't over. Many survivors would soon begin suffering from burns, radiation sickness, and long-term illnesses. And just 3 days later, another atomic bomb would fall on the Japanese city of Nagasaki. Those two bombings together are known today as the atomic bombings of Hiroshima and Nagasaki. They changed warfare forever and marked the beginning of the nuclear age, a time when humanity suddenly possessed the power to destroy entire cities in seconds. And that moment in Hiroshima remains one of the most powerful and tragic turning points in human history. To understand why the atomic bomb was used, we need to go back to the intense years of World War II. By the early 1940s, the war had spread across Europe, Asia, and the Pacific. Millions of soldiers and civilians had already died. The United States and its allies were fighting against powerful countries like Germany and Japan. During this time, scientists discovered something extraordinary in the field of nuclear physics, the possibility of releasing enormous energy from the atom. In 1938, scientists in Europe discovered a process called nuclear fission. This process showed that when the nucleus of a heavy atom splits, it releases a massive amount of energy. Some scientists quickly realized something frightening. If this reaction could be controlled and multiplied in a chain reaction, it might create a weapon far more powerful than any bomb ever built. At the same time, many scientists feared that Nazi Germany might develop this weapon first. Famous physicist Albert Einstein, along with other scientists, warned the United States government about this danger. They believed that if Germany developed an atomic bomb first, the consequences could be catastrophic. Because of this fear, the United States secretly started one of the largest scientific projects in history. It was called the Manhattan Project. This project began in 1942 and involved more than 130,000 scientists, engineers, and workers. The program was extremely secret. Even many of the people working on it didn't know the full purpose of the project. The scientific leader of the project was J. Robert Oppenheimer. He and his team worked in laboratories and secret facilities across the United States, trying to design the world's first nuclear weapon. After years of research and testing, the scientists finally succeeded. On July 16, 1945, the world's first nuclear explosion took place in the desert of New Mexico. This test was called the Trinity test. When the bomb exploded, the scientists watching it were shocked by the incredible power they had created. A huge fireball lit up the desert, and a massive mushroom cloud rose into the sky. At that moment, humanity had entered a completely new era, the nuclear age. But only a few weeks later, this powerful and terrifying technology would be used in real war, and the target would be the Japanese city of Hiroshima. Now the question is, how does an atomic bomb actually work? To understand this, we first need to understand a basic concept of nuclear physics called nuclear fission. Everything in the universe is made of atoms. Inside every atom is a central core called the nucleus, which holds a tremendous amount of energy. Normally, that energy stays locked inside the atom. But when the nucleus of certain heavy elements is split, a huge amount of energy is suddenly released. Two of the most important elements used in nuclear weapons are uranium-235 and plutonium-239. These elements are called fissile materials, meaning their atoms can easily split. Here is where the real power comes from. When one atom of uranium or plutonium splits, it releases a massive burst of energy, several fast-moving neutrons, and intense heat and radiation. Those released neutrons then hit other nearby atoms, causing them to split as well. This process repeats again and again extremely fast. This is called a chain reaction. Inside an atomic bomb, this chain reaction happens billions of times in less than a second. In that tiny moment, an enormous amount of energy is released. That energy instantly turns into three main destructive forces. Extreme heat. The temperature inside the explosion can reach millions of degrees, even hotter than the surface of the sun. Blast pressure. A powerful shockwave spreads outward at incredible speed, destroying buildings, roads, and everything in its path. Radiation. Invisible but extremely dangerous nuclear radiation spreads through the area, damaging human cells and causing long-term illness. Because of this reaction, nuclear weapons are thousands of times more powerful than conventional bombs. For example, the bomb dropped on Hiroshima, known as Little Boy, released energy equal to about 15,000 tons of TNT. And that was only the beginning. Later, nuclear weapons became hundreds or even thousands of times more powerful. This is why nuclear weapons are considered the most destructive weapons ever created by humans. When the atomic bomb exploded above Hiroshima, the destruction happened in just a few seconds. The bomb, known as Little Boy, detonated about 600 meters above the city. Exploding in the air allowed the blast to spread across a much larger area, making the destruction even more devastating. Within seconds, four major effects struck the city. One blinding flash of light. The first thing people saw was an extremely bright flash of light. It was brighter than the sun. People several kilometers away were temporarily blinded. Some survivors later said the sky suddenly turned white and blue, followed by darkness and chaos. Many people who were looking toward the explosion suffered permanent eye damage. Too extreme heat. The explosion created an intense fireball in the sky. Temperatures near the center of the blast reached about 3,000 to 4,000 degrees Celsius. That heat spread outward rapidly. Clothes caught fire instantly. Wooden buildings burst into flames. People even several kilometers away suffered severe skin burns. In some areas, the heat was so intense that human shadows were burned onto walls and streets, leaving permanent marks where people had been standing. 3. Massive shockwave. After the flash and heat came the blast wave. This powerful shockwave moved through the city at incredible speed. The pressure from the explosion destroyed nearly 70% of Hiroshima's buildings. Homes collapsed, bridges were damaged, windows shattered up to 15 kilometers away. People were thrown through the air by the force of the blast. Entire neighborhoods disappeared within seconds. The mushroom cloud. As the explosion continued, hot air and debris rose rapidly into the sky. This created the famous mushroom-shaped cloud associated with nuclear explosions. The cloud continued rising until it reached nearly 12 kilometers above the Earth. Inside this cloud were dust, debris, smoke, and radioactive particles. These particles would later fall back to the ground as radioactive fallout, spreading contamination across a large area. In just a few moments, the city of Hiroshima was transformed into a burning ruin. Tens of thousands of people had already died. But for many survivors, the worst effects of the atomic bomb were still to come. Because unlike normal weapons, nuclear bombs also release dangerous radiation that can harm people long after the explosion. After the explosion in Hiroshima, many people who survived the initial blast believed the worst was over. But the atomic bomb had released something invisible and extremely dangerous: nuclear radiation. Unlike fire or explosions, radiation cannot be seen or smelled. yet it can severely damage the human body. When the bomb known as Little Boy exploded, it released powerful gamma rays and neutrons that spread throughout the city. People who were exposed to high levels of radiation soon began suffering from a condition called acute radiation syndrome. At first, many survivors experienced symptoms such as severe nausea and vomiting, extreme weakness and fatigue, high fever, hair suddenly falling out, and bleeding from the nose and gums. Doctors at that time did not fully understand radiation sickness, so they struggled to treat the victims. Some people who looked perfectly healthy right after the explosion suddenly became very sick days or weeks later. Radiation had silently damaged their cells. Over the following years, another serious problem began to appear. Many survivors developed leukemia, a dangerous form of cancer that affects the blood and bone marrow. Scientists later discovered that radiation exposure had damaged the DNA inside human cells, increasing the risk of cancer. The survivors of the atomic bombings are known in Japan as hibakusha. Many hibakusha faced lifelong health problems. Some suffered from different types of cancer, while others experienced chronic illnesses caused by radiation exposure. There were also fears about genetic damage. People worried that children born to survivors might suffer from birth defects or genetic mutations. Because of these long-term effects, the bombings of Hiroshima and Nagasaki became a global warning about the terrifying power of nuclear weapons. The explosions did not just destroy cities in seconds, they also caused suffering that lasted for decades. And this tragedy forced the world to ask a serious question. Should humanity ever use nuclear weapons again? After Hiroshima and Nagasaki, the world realized the terrifying power of nuclear weapons. But the story didn't end there. Instead, it began a new era of global military tension known as the nuclear age. Today, nuclear weapons are far more powerful than the bombs used in 1945. Modern warheads can release energy hundreds or even thousands of times stronger than the Hiroshima bomb. Some weapons today are called thermonuclear bombs or hydrogen bombs, which use a combination of nuclear fission and fusion to produce massive explosions. The development of these weapons created a new concept: mutually assured destruction, MAD. This means that if two nuclear-armed countries go to war, both could be completely destroyed, making full-scale nuclear conflict almost unthinkable. Currently, about a dozen countries possess nuclear weapons. The most powerful arsenals are in United States, Russia, China, France, United Kingdom. Smaller arsenals exist in countries like India, Pakistan, Israel, and North Korea. Nuclear weapons today are heavily guarded, and international treaties like the Non-Proliferation Treaty, NPT, aim to prevent the spread of nuclear weapons and reduce the risk of war. Even with these measures, the threat remains. Modern nuclear weapons can destroy entire cities in seconds, contaminate regions with radiation for decades, and even have global environmental consequences, like nuclear winter. In short, nuclear weapons are no longer just a historical event. They are a present-day reality. Humanity now lives in a world where a single mistake could lead to catastrophic consequences, making awareness, diplomacy, and international cooperation more important than ever. The story of Hiroshima teaches us both the history of human innovation and the responsibility that comes with such devastating power. After the atomic bombs were used in Hiroshima and Nagasaki, scientists realized something frightening. The atomic bombs used in 1945 were already extremely destructive, but they were only the first generation of nuclear weapons. Soon after World War II, scientists began working on an even more powerful type of nuclear weapon called the hydrogen bomb, also known as a thermonuclear bomb. Unlike atomic bombs that use nuclear fission, hydrogen bombs work using another nuclear process called nuclear fusion. Fusion is the same process that powers the sun. In fusion, light atoms combine together instead of splitting apart. When these atoms fuse, they release an enormous amount of energy, even more than fission. But fusion requires extremely high temperatures and pressure to begin. So here's the shocking part. A hydrogen bomb actually uses an atomic bomb as its trigger. First, a small fission bomb explodes. That explosion creates temperatures of millions of degrees, which then triggers the fusion reaction inside the hydrogen bomb. Once fusion begins, the energy released becomes far greater than the original atomic explosion. The first hydrogen bomb test in history was conducted by the United States in 1952. The test was called Ivy Mike. When the bomb exploded, it produced a fireball several kilometers wide. The explosion was so powerful that it completely destroyed a small island in the Pacific Ocean. The energy released was about 10 million tons of TNT. That is hundreds of times more powerful than the bomb dropped on Hiroshima. Soon after, another nuclear superpower, Soviet Union, also developed its own hydrogen bomb. This began a dangerous competition known as the nuclear arms race, where countries tried to build bigger and more powerful nuclear weapons. Later, the most powerful nuclear bomb ever created was tested by the Soviet Union in 1961. It was called the Tsar Bomba. Its explosion was 50 million tons of TNT. Windows shattered hundreds of kilometers away, and the mushroom cloud reached over 60 kilometers into the sky. This showed the world that nuclear weapons had become powerful enough to destroy entire regions, not just cities. And it raised a terrifying question for humanity. If such weapons were ever used in a large war, could they destroy civilization itself? After the invention of the hydrogen bomb, the world entered a new and dangerous era called the nuclear arms race. During the Cold War, roughly from 1947 to 1991, the two superpowers, United States and Soviet Union, competed to build more and more nuclear weapons. Each country wanted to ensure it had enough firepower to deter the other from attacking. This concept is called mutually assured destruction, MAD. Both countries developed massive stockpiles of nuclear weapons, thousands of strategic warheads capable of destroying cities, long-range missiles that could reach anywhere on Earth within minutes, submarine-launched missiles to maintain a second strike capability, ensuring retaliation, even if the homeland was attacked first. This competition was not just limited to the US and the Soviet Union. Other countries soon joined the nuclear club: United Kingdom, France, China. Later, countries like India, Pakistan, Israel, and North Korea developed nuclear weapons as well, raising concerns about regional conflicts turning nuclear. The arms race created constant fear. Every new test, every new missile made people around the world realize that a nuclear war could happen by accident, miscalculation, or escalation. Because of this, international treaties were established to control and reduce nuclear weapons. Non-Proliferation Treaty, NPT, to prevent more countries from acquiring nuclear weapons. Strategic Arms Reduction Treaty, START, to limit the number of warheads between superpowers. Despite these efforts, the threat of nuclear weapons remains real today. Even a limited nuclear conflict could cause catastrophic destruction, not only for the countries involved, but for the entire planet, through radiation, environmental damage, and global climate effects. The nuclear arms race taught humanity a crucial lesson. Power without control can become a global nightmare. Today, nuclear weapons are no longer just a threat between superpowers. They exist in multiple countries around the world, each with its own arsenal and capabilities. The countries officially recognized as nuclear powers under the Non-Proliferation Treaty, NPT, are 1. United States, the first country to develop nuclear weapons and the only one to use them in war. It currently has thousands of warheads and advanced delivery systems, including missiles, submarines, and strategic bombers. 2. Russia inherited the Soviet Union's massive arsenal. Russia has the largest stockpile of nuclear warheads in the world, with advanced intercontinental ballistic missiles, ICBMs, capable of reaching any continent. 3. United Kingdom maintains a smaller but highly advanced nuclear arsenal, primarily submarine-launched ballistic missiles for a secure second strike capability. 4. France uses both land-based missiles and nuclear submarines. France emphasizes a strategy of deterrence rather than mass stockpiles. 5. China has been rapidly modernizing its nuclear forces, including missiles capable of striking distant countries. China focuses on a smaller, secure arsenal designed for deterrence. Other countries outside the NPT have also developed nuclear weapons. India maintains a growing nuclear program and delivery systems, mostly for regional deterrence. Pakistan developed nuclear weapons in response to India, with missiles capable of reaching its neighbor and beyond. Israel maintains a policy of ambiguity, but is believed to have nuclear weapons for deterrence in the Middle East. North Korea The newest and most unpredictable nuclear power with ongoing tests and missile development, the presence of nuclear weapons in multiple countries increases the risk of regional conflicts escalating. Even a small nuclear exchange could cause massive loss of life, long-lasting radiation contamination, global climate effects known as nuclear winter, which could affect food supply worldwide. International organizations and treaties aim to limit nuclear proliferation, promote dialogue, and prevent nuclear war. The lesson is clear. The more nuclear weapons exist, the greater the responsibility humanity has to prevent their use. If a nuclear war ever happened, the consequences would be catastrophic, not just for the countries involved, but for the entire planet. Even a limited nuclear exchange could destroy cities instantly, killing millions of people. Hospitals, schools, and infrastructure would vanish in seconds, leaving survivors without food, water, or medical care. But the effects would not stop there. Nuclear explosions release enormous amounts of radioactive fallout, contaminating the air, water, and soil. Radiation can travel hundreds or even thousands of kilometers, causing sickness, cancer, and birth defects for decades. Scientists also warn about nuclear winter. When nuclear bombs detonate, they create massive fires that send soot and smoke into the atmosphere. This can block sunlight, lower global temperatures, and disrupt weather patterns. Crops could fail worldwide, leading to famine and food shortages even in countries far from the conflict. Beyond the environmental and human cost, nuclear war would destabilize the world economy, destroy infrastructure, and trigger mass migration, creating global humanitarian crises. The tragedy of Hiroshima and Nagasaki bombings shows us only a glimpse of this power. Today's nuclear weapons are hundreds of times more powerful, capable of wiping out entire nations in minutes. That is why global efforts like the Treaty on the Prohibition of Nuclear Weapons exist, to prevent nuclear war and promote disarmament. Humanity now faces a choice. Will we continue to build weapons capable of total destruction? Or will we learn from history, work together, and ensure nuclear weapons are never used again? The story of nuclear weapons is a reminder. Power without control can destroy civilizations, but responsibility and diplomacy can protect them. The atomic age began in Hiroshima and Nagasaki, and it is up to us to make sure it does not end the world.